Welcome to this webinar about concrete design improvement in FEM-Design 18. My name is Hanif Lomo and I'm working as support engineer in Strosoft, Denmark. And I have also my colleague, Frank Zakla, from our office in Budapest, and he will answer your questions. So as I mentioned before, the main topic is about concrete. So we will go through the topics or the agendas that has effect on the concrete design. So as you can see, the topics are mesh generation and peak smoothing, introduction of interaction surface for our C-bar design, applying no-shear region or disabling them, punching improvement, and introduction of detail reader for concrete walls. So let's start with the first topic. Hopefully everyone could attend the second webinar. So we are really sorry that you guys couldn't participate in the first one because this software that we use it. It has a limitation of around 100 participants each time. So as there was a lot of interest, so we didn't expect it that much participants. So afterwards we divided it into two. So hopefully everyone could now attend it. So let's start with the mesh. I'm going to open one of the models here. So we are looking only one story, so we don't need all of these. One of the changes that it happened in FEM-Design 18 is that now the peak smoothing and mesh, they are not connected to each other in a way that previously, if you applied it, for example, peak smoothing, the mesh automatically changed, and it FEM-Design created fine mesh around the area of the peak smoothing, and this generated a lot of mesh problem, especially in cases like this where they overlap each other. So they generated fine mesh in this area where they overlap or cross each other. So now that's why we have improved it, and now they are independent from each other. And previously the defaults, previously peak smoothing was not on automatically by default. Right now in FEM-Design 18, if you model something, it's automatically on. So let's see the changes first in the settings. As you can see here, previously this peak smoothing was part or connected to the mesh, so that's why it was here under it. But now we have separated it, so it has its own. As you can see here, it's called peak smoothing, and if you click here, here's the method, and we have also divided it to different groups. So the first one is, you can see the internal forces of moment and my and mxy, and here we have the in x the axial forces, and here we have the shear forces. As you can see, you have 4 options. Don't smooth, so it means it doesn't smooth, and then you have this use higher shape order function, and then you have use constant shape function and set to 0. I think it will be best if I show you in a picture how it is. As you can see here, this is a plate with some point support at the corner, and in the middle you have a columns, and you can see it's applied peak smoothing. And if you can see here, don't smooth. So if it doesn't smooth, you can see here this peak, which is theoretically, yeah, infinite. So, and it's unrealistic if you don't have this peak smoothing on. And then you have this use constant shape function, which is the previous version of FEM-Design had. as you can see here, it's so the function was that it cut it the top or the peaks and then distribute it to a bigger area. And this is the new one where you have the we call it higher order shape function, as you can see it here, and you can see it's smoothed like a parabola. So and you can and this one is automatically on by default. So if we go here, so let's first see this one. As you can see here, there's no peak smoothing on in this one, and you can see these peaks. And if we go and you can see I can turn it on the peak smoothing, but first we are going to look at what's the configuration in the settings. As you can see here, it's used higher shape function. By default, these are set, so all of them are set to these ones. And then we have the automatic setting, which is also by default set to columns and point support. And of course, you have the option to turn it on for others as well, or you can draw your own peak smoothing in a region if you want. And if you click here, you can see you can just draw it for a part. And be careful with the usage of this, so you shouldn't apply it for a large area, otherwise it smooth all of the moment. And also depends which one you use from here, especially if you use set to 0 or use to constant shape. So so now with the peak smoothing on, so let's turn it on and do a recalculation. So see how those peaks are now smoothed out with the higher order function shape. Yeah, it take a few seconds now. Yeah, it's finished. As you can see now, they are smoothed out those unrealistic peaks. And this higher order shape function is really good, also especially for the case of shear force. If you go here, especially if this one is used, if you use higher order shape function for the shear force, because then this one you can see the benefit. If you use, for example, this one is kind of flat out completely, and this one is you can see a smooth transaction. If we go back to analysis and go back to shell internal forces, and if we click on this one, oh, it's not the section, so let's turn on the section. As you can see, it's really smooth transaction from one to another in here. So we recommend you guys, if you use the peak smoothing, use this one especially for the shear force. It's really smooth. So this is the peak smoothing, and then let's look at what we have, the other topic, and then let's go to this one, interaction surface, see what's changed there. So if we pin here a model, and again we have the same model, so we are going to look at for the reinforcement rebar design. So we go to RC design, and here this one is the first one, so bar design, and we can do first, maybe it's good to do an auto design. So let's do an auto design for this one. We can click here to change the parameters. So I use maybe Y for this one, and diameter maybe 6, and also again why here, if you are not sure what this naming system, then you can see here that K is about 500 and Y is about 550. So I use this one again here, and here we have the longitudinal, and the first one was the stirrup. Longitudinal are these ones, and then we have the longitudinal auxiliary. It means if these ones were not enough, FEM-Design will add some more auxiliary one or additional one, and it will be, we choose that it should be also the same, based the same as this one. So it apply also 16, and we say we are happy with this cover. It's 20 here, so say okay, and then we do the design. So it's finished. You can see the utilization here. So now if we go to the detail, to the manual design, if I right click here, the one that we used auto design, you can see here the interaction surface, which is new, didn't exist in the previous version. And here you can see the MZ. So in this axis and MY in this axis, and here we have the normal force in this axis. So you can either click here, then this result window get activated, or this one also shows up here. So you have, yeah, you can choose which one you want. Select here, select on the result, and this one shows up. And here we have the interaction surface. If you don't want the interaction surface, you have the option to display like the summary, to see like in a summary of it, different utilization figure for the section stirrup concrete and for the torsion. And we can go back to interaction, and then you can display it for the ultimate or accidental. So the reason for this separation is because the material properties are different with different partial coefficient. And here you have the option to either click here or here to make a section horizontal cut. So you can make a cut, something like this, a 2D cut of it. So you can choose for a specific normal force. As you can see, it's this one, the horizontal one, so it's the normal force. So we can say, for example, 320 kilonewton. See how it looks like, and where its positions. You can see it here, and here we can see the, yeah, kind of the diagram of it. And if you click back here, then it shows the 3D again, and you can select the vertical cut. So if you click here, then you can define the angle, which angle you want, for example, yeah, 45 or something. And it shows, as you can see, also the axis and where it's located here. And you have, if you click back, then it's 3D view, and you have the option to either use the automatic calculate, or you can use this user-defined MN ratio. So you can put your own value, and here we have the tolerance you can also do. And another thing is that this is live or dynamic. So if we see, this shows this position. If we move it a little bit here, we can see it's also dynamic. It changes, it shows where we are, and here we have this reinforcement. So it's a section. It just shows, yeah, we are in the section and everything. So I just moved this one a little bit down. So if you have question, you're welcome to type it here, as I mentioned. So you can type in your question here. So my colleague will try to answer them. If we couldn't answer all of them today, then we will get back to you tomorrow or afterwards, and we will send answer to your question plus the YouTube video. We are going to upload this to YouTube, so the link for it. So as I mentioned, this is dynamic, so you can let's see if we go side view again. So we can go here, and if we are not happy with this layout of reinforcement, we can of course change it. We say we don't want this configuration, so let's change it. Longitudinal, so we say we don't like these, so we're going to delete them. See, as you can see, they are dynamic, this changes. And here we can use this 3 of them in 2 rows. So let's see, from here to here and inside, and it should start from here, or we can stop wherever we want, but we want it all the way. So here, and we can also position here. So here, say from here to here. So you can see there's no green or red dot. So if the red dot is outside, it means that it's filled, but none of them exist here because we haven't checked, press on the check or OK. Previously, it wasn't possible, but right now it's possible because we have added it here. Before, you had to come out of this one and then it did the check. But right now, you can just press OK. Let's do the calculation. As you can see, this green dot appears, so it's inside of the interaction surface. So if we are happy with this configuration, then we can just press OK, and then we come back to here, and if we want, we can go to utilization, and if you right click on this particular beam that we have designed, you can see here at the detailed result of it. So it's calculated here. And you can see this for the maximum of load combination. If you have different ones, so then you can check for one load combination. And you have the ability to export this either to AutoCAD, this part of it, or you can export the all calculation in a Word file or HTML or MATCAD 15 worksheet. So you have the ability to export them. I think that's it for the interaction surface. So let's take another topic. We can look at the detailed result. Open that one. Yeah, let's remove all of these. C-bar. So previously it wasn't possible to see for the plate a detailed result. So we could just look at this required reinforcement and see how much reinforcement we needed. In the current version, it's possible to see a detailed result of it, to see how FEM-Design calculated it. So let's see how we can do that. First, as always, like previous version and the current version, you define the calculation parameters, and here you can set your configuration. We say it should be steel quality Y with this diameter and cover. If you want, you can also define the crack width for the bottom, and also here you can define for the top, and also the same for the top part. You can define your configuration, and here you have, if possible, do not use reinforcement or apply minimum reinforcement when it's relevant. So you can define it here in the calculation parameter. So, and you can see it here, and here is the X direction and the one that we have chosen. So if we do a check, let's do a check, and here we can look at the design forces. For example, previously you should have gone to this one, required reinforcement, and checked how much you needed. So you didn't know how FEM-Design come up with that value. But in this version, it's possible to see how required reinforcement is calculated. So as you can see here, this button is new. So it's this magnifier, it's the detailed result. So if you click here, this dialog box shows up. So you can right click and select a point, then the detailed result will be displayed. If you click here, then you can change the property, the naming and stuff. And then you have this one. If you have defined some different points, points in here, maybe here, then you can select it by this. And with this one, you can erase those points. So, and as you can see here, display result is on. If display result is on, as soon as you click and choose a point, it will take you to the detailed result. If this one is not on, so you can just click and choose different points in the plate, and then you can use this to select each one of them, and then you can use this one to just delete them. So in this case, I'm going to look at this maximum design force for MX bottom. If you are wondering how we calculate these design forces, we have, if you go here to help manuals, it takes you to this FEM-Design wiki, and then you have the verification example. And if you click here, then there is a PDF with a lot of verification example, different verification example on different topics. So you can go through them, and there is, of course, also the design of RC plate. So there you can see how it's calculated, these MX design forces, and also for other ones. So we can select this, and I just right click and select this one because this is the maximum. So I click here. Let's see, nothing happened. Just second design display. So detailed result, this point, display result is off, so I can just choose this one. It takes media. It takes a few seconds to calculate that one because it's going to prepare the calculation. As you can see here, it shows the geometry, the global coordinate system of the point that I have chosen. It's here, and here it says about, or shows the reinforcement direction. It's 90 degrees, and also the thickness of the plate. And here you can see the shell local coordinate system. The green one is, as you can see, the X, and the Y is the red one. And you can also see the reinforcement layout. The X is this direction, as you can see, and Y is that direction. That one is for the reinforcement. And here you can see the concrete and their property and some of the calculation, how they are done and where they are coming from. And you can see this refers to the Eurocode, this part. And here you can see the applied reinforcement we haven't applied yet, so that's why there's no applied reinforcement is mentioned here. And here we have the equivalent reinforcement, which is based on the initial parameter that we have set. You can see here the Y and 10 and the cover, and we haven't applied, so that's why it's empty. And here we have the other calculation parameter that was also in the initial parameter dialog box. It's allowed crack and minimum reinforcement and compressed, we set to no. And here for the required reinforcement bottom X, it's set that this is the leading load combination. And here is the internal forces, and here we have the design forces. So the design forces usually is the MX, or for example in this example, and plus the MXY. So, but as I mentioned, you can see clearly the calculation in the verification example. So here are the design forces for MX bottom and for the NX, and here you have the MY bottom and the NY, and also the MX top and MY top. As you can see here, it says that it's based on the wood armor and name it methods. And here we are going to design the maximum reinforcement, which is around 4% according to Eurocode. As it says, it's referred to the Eurocode and which part of it. And if we look at this, you can just move them, scroll, and you can use all the function of the mouse here. So here is the MN combinations, and here you can see for the bottom X, and you can see the sign. So this is the plus and the minus sign. We have, as you can see, we have around 8 because we have 8 for reinforcement, and of course this the sign, so that's why we have around 8 cases. So we can look at the case number 1. Here is the design force. As you can see, it's the same as here, the design force, and we have the normal force. Here it's going to illustrate it in a figure. So how it is, you can see that it's in tension, and this value is, as you can see, the NX, and here we have the moment, that's this value, and here you can see the strain, and here you can see the stress. The stress is the upper part of this cross section, and here you have which the concrete takes, and here is the reinforcement which takes the tension, and you can see this upper part is shown in megapascal, and this one is shown in like a force. This one we have done so if you wanted to do compression, so it was easier to find the equilibrium this way. And here we have, as you can see, it says the tension reinforcement. This is the case, so it's give also a name and how it is. And here we have the bottom X. This is this option, and you can see the same moment, and then it's the compression. So again, it's display the stress and strain. And if we move forward to this part, now we are here for the top X, and you can see here the moment is 0. Then we have the tension. So you can see it's also displayed it here for this, for the stress here and here. The reinforcement is going to take them, and here we have the compression. As you can see, it says fully compressed, and here you can see the value. So these ones is just repeat here, the same and the same and the same here. So now we know how much reinforcement we need. As you can see here, the values are displayed here. It's based on the design force, but according to Eurocode, we also have to calculate a minimum requirements, and it's done here. As you can see here, minimum reinforcement, and it's calculated for the bottom X 341, which is bigger than this value. So then we need this amount of reinforcement if we apply the minimum reinforcement. And then here we have the interaction curves. As you can see, these dots are outside because we haven't applied any reinforcement. After we apply the reinforcement, we hope that it should be inside. So for the utilization, we haven't applied any reinforcement. That's why it shows just 1000%. And you can see here, it's now investigating for required reinforcement bottom Y, and you can see that it's the same load combination as this one. So we don't need to, because it will do the same calculation again, because it's the same load combination. So here we can just choose this one, and then it will be more concise because the load combination in every case is this one. So that's why we choose this one. And here, as you can see, it's more concise. And in the next part, you can see here, it's also done a shear capacity check based on the internal forces, and you can see it here, a detailed result. If we apply reinforcement, if and afterwards we do a shell buckling, it will also appear here. It's a long calculation. And of course, if we after we applied our reinforcement and we were happy with that, then we can run a crack width analysis, and the calculation, the detailed calculation will also appear here. But right now we haven't done any of those, so we can go back. And now if we look at this, so as you can see, yeah, it's 341, so that's amount we need. So it's based on the minimum reinforcement. So you know now how these values are calculated. So we can look at for the Y bottom, and this is this amount, and here we can see the X is around this amount, and here for the Y top it's around this amount. So we know how much reinforcement we need. So we can either use manual design or auto design. So in this case we use the auto design, and then you can see it's plate 1-1 and it's blinking or flashing, so it means that this one is selected. So we can go to parameters, and then here we can define the reinforcement. So we say Y 10-10, and here the area, so it's automatically change this area if we change something else, for example this one. But we are going to keep this one because this is just for the sake of example, and this is for the base net, and here we have the additional reinforcement. So if it's required, it will apply the additional reinforcement if this one is not enough. And here is a new button that's appeared in FEM-Design 18. So previously you had to define for the bottom face, and then you have to go to the top face and define it there as well. But right now, if you check mark this one, so if you check mark it, the same reinforcement will be applied also on the top face. So we say we are happy the same reinforcement should apply also on the top face. We press OK, and let's do a design. So now FEM-Design design. So everything looks fine. So now we can go to detailed result, and there will show also the applied reinforcement. So that's possible to go from, if you are here, you can go from design forces, required reinforcement, and missing reinforcement, and also from these areas shell buckling. But it will not be possible from applied reinforcement. As you can see, if I click here, the icon is gray, so it's possible from the other ones. If I click here for the required reinforcement, and then if I go here and select here, right click, and if I choose this one, for example, that point, then it will take me to the detailed result. As you can see here, it shows again that I have chosen this point, this particular point. So here is the applied reinforcement. As you can see, this one is also added, the applied reinforcement, the equivalent reinforcement, and the rest will be the same detailed result, so how it's calculated and everything. So as we have only one load combination, so I'm going to keep this one just to decrease the amount of the detailed result it's going to display. And the same here, we haven't done any shell buckling and crack width calculation. And you can see these here also, these are some new icons that appeared in FEM-Design 18. So you can choose zoom margin, or you can use this one, zoom weight or zoom height, then it's going to automatically fit the height. So that's the way you display the detailed result for shell elements, either for plate or for the wall. So we can go back here. Another feature that it's added is this no-shear. So by default, this no-shear is on. So previously, if you were designing plate a lot of these plates showed not okay in the shear capacity. In FEM-Design, you don't design, it's not possible, or FEM-Design doesn't do the design of shear. So that's why a lot of customer or user requested that if we could select the areas where we don't want to check for the shear, and that's done by default in FEM-Design. So if I click on this one, you can see it here, these regions appear. Maybe here it's not so obvious, but if I remove those results, you can see here, these are appear here. These are the no-shear region, so it's not going to investigate for this region for the shear capacity. As you can see it here, these are the areas. And of course, you have the option to draw your own region. And also, if you don't want this no-shear, you can deactivate them or make them inactive. So if you go here in the property, and this is the only way, otherwise you can't delete them. You can't use this function and delete them. The only way to deactivate them, it will be this one. You can either select one of them, and here you have, of course, the option to change this x. As you can see, x is multiplied by h, so you can change this value or make it inactive. In this case, just for the sake of illustration, I'm going to select all of them at once and say they are inactive. So press OK. Now they are inactive. If I do a recheck, you can see that now it shows that the shear capacity is not OK. So if you want it, you can go to the shear capacity missing, and then it will show which part or area it needs shear reinforcement, and it will also show the unit here. So another, a lot of users requested that if it was possible for them to export this maximum force as one value. Previously, if you want to export it, the internal force, FEM-Design exported the internal force for every node in this place, and it was 1,000 of result for one plate. So right now it's you can do it. You can export only as one result, the maximum. For example, if I select this listing, right click here, and I go to load combination or maximum of load combination. So you decide which one. Then these ones appear. As you can see, this is new. So extract is like it's only show the maximum ones. So here we can choose internal forces and this load combination, and then we can send it to documentation. So let's send it, list tables, and let's go to documentation. You can see it's appear here and as one value. Previously, it would have displayed a long list for every node, and here it shows only for this node. This is the mx positive, so this is the value. You can see it here, and for the other one. So, and if you want, you can extend this one a little bit, so you can. Oh, maybe I extend it too much. So here, and then you can of course see the load combination, or maybe make them more smaller compared to this one. So this is also a new feature that came in FEM-Design 18. So let's see what subject is left. So punching improvement. Let's go through some punching improvement. If you go here, punching presentation. So in FEM-Design 18, we have added these two new ones, stud rail, the general product, and this one is for the Pico one. So these are these one that you can see here. If I click here, then you have these options. You have the radial, which is this one, you can do it in FEM-Design now, and you have the orthogonal, which is this one, you can do it now, and also the semi-orthogonal, which is this one. So you can see if I zoom a little bit, you can see this is the orthogonal part, and yeah, it's a semi, so you can see the other part here. So this it's possible to do that, and here you can define the number of rails and the number of studs, and here you can set the if you want, you can manually set the S0, S1 in here, or if you press on that button, you can also define it here. Otherwise, you can use the auto set. As you can see, it's the diameter and also the number of rail studs, and also this S0, S1, S2. You can see here, and FEM-Design calculate the height automatically. Otherwise, you can do it and use only 2 or 3 elements rail. And this one is here. You can see it. So this is like the prefabricated one. If you use this one, then we'll use this too. If you don't use it, then you can see it here. So this is the difference. This is for in case you use it, the prefabricated ones. So these are the new features, and let's look at the result of this, for example, for this one. And you can see here this is a Pico one, and it has some special certification or verification. It's this ATA, and this is, if you search for it, then you can find more information about it on their website. And also this you can see here previously, if you displayed the detailed result, FEM-Design would have shown the reinforcement also in this area, which is outside the boundary of the plate. So in the current version, it's cut out those areas, and it shows only which is inside the boundary of the plate. And if we look at another new improvement is in this area, if you have different thickness. Previously, it wasn't possible to do punching calculation for such a case. Right now, it's possible, but you have to manually define the effective. You can see it has two, the thickness are not the same. So if we go back here, if we click on this one and right click here, so this calculation parameter shows up. So these two are new. The effective slab depth for such a case where you have two thickness, then you have to manually calculate it and insert it here. And we have also added this option, shear reinforced resistant limit, that you can manually define to your desired value here. And another improvement is if we look at this one, this result, for example, as you can see here, when we look at the U0 value, it's taken into consideration from here, from this point. But in real life, this column is usually inside the boundary of this plate. So previously, you would have drawn this one inside of the plate for each one of these column or this shear region. But in the current version, we have changed it. So you have the option to do it in here. So if you go to the plate, then you press on this one, physical extend, then you right click on the plate that you want to extend, then you right click on the edge. This edge is selected, then I see that it should be extended around 175. Extend it this direction, and I'm going to do also for this, and it's 125. You can see it here. If I turn it on, now they have the same boundary. So if I go back to RC design, and if I do a check for this and look at the detailed result for this, you can see this U is now different. So now it's 600. So these parameters are going to be changed, and the boundaries are also now in the inside. So and again, for this you have the auto design for both of these, and the rest are the same. These three existed also in the previous version, so these two are new. And this was for the punching. And again, if you have questions, you are welcome to type them in that dialog box that I showed you earlier. So I think let's go to the last topic, which is the Conceal Bar. So let's look at our C design. As you can see here, we have this one. It's new, Conceal Bar. And in this, the reason we have added this Conceal Bar is a lot of users, they wanted to have the option to manually design this part of the wall as a bar, for example. So you have that option right now, and also they wanted to get the internal forces, for example, here, to easily display the internal forces, especially for the prefab element producer. They only want the internal forces, and based on the internal forces of that particular beam or column, they will do the design. So let's do that. We go here to this one, is specify. As you can see, this one is specify Conceal Bar. So we can either select this rectangular and draw it, or use this existing. So we are going to draw it. We say this one we are going to make it as a fictive or a concealed bar. So we have drawn that. As you can see, there's a fictitious bar here. So we can do the design now. It's exactly like our RC bar. So we can go here, and then we can look at the properties. We can say we use, for example, 6, 16, and 16 again. So click OK, and then do the design. So we can go to utilization and see that now this part of the wall is reinforced as a column. So you can see here the stirrups and everything, and this is the detailed result. And you'll be also able to display the internal forces. For example, if I look at the normal forces, now you can see here, it's going to display like a bar. So this is the simplification that this concealed bar can do for you guys. So, and you have the option to group it or manually design it. So you can go here and then do the manual design if you want. And you have also have the option to copy this one, for example, from here to here. And it's the important part is that if you use this concealed bar, there shouldn't be any hole, so the section should be continuous. So, and maybe we can draw one here for this part. If you want internal forces in this part, especially in here, how much it is, we can do that. We can just choose this one, and here you have also the option to use this one, user defined. So if I click here, I can see in this direction, then I can draw also something like this. It's maybe a little bit unrealistic, so you can remove this one. So we go back to here and choose again this one, local, and here I can draw this part. So now it's like a fictitious beam. So you can see it here. So I can do the design. In order to display the internal forces, so you have to design it. So we go here and say 6 and 6 and maybe 16 again. So do the design. So here it shows the normal force or the axial force, and we can display maybe the moment. You can see here now it's display the moment. So you can just send this diagram and with its value, then the prefab element producer can use it to design this one as a beam. And that's it. So do you have any question? As I mentioned, you are welcome to type your question here. If you have further question, you can just send it to our support email. Then we will try to get back to you.